Hello everyone, welcome back to the next lecture of double integration, and the topic is change the order of integration. In continuation of previous lecture, we have new example, change the order of integration and evaluate integral from 0 to 1, then root x to 1, 3y cube into e raised to xy dx dy. Now as already said, these four limits are nothing but the four curves. Now inner integral limits are the functions of x, that's why they are the limits of y. Lower limit of y is root x, therefore y equal to root x gives us y square equal to x, a parabola. Then upper limit is y equal to 1, a straight line. Then x varying from 0 to 1, so 0 and 1, these are the straight lines. If we draw all these curves, we get this bounded region. So question is, why only this is the bounded region, why not this one and this one? So from the limits we can identify where x is varying from 0 to 1. So for these 4 curves, x is varying from 0 to 1. But only for this curve, y is varying from parabola to a straight line y equal to 1. So only this region gives us or satisfying the given conditions. Therefore, when we sketch, we get area of integration. Now, inner integral limits are of y. That's why given strip is vertical. That is for y. This way, given order of integration was y and then x, and we change the order of integration. We first solve for x and then y and then evaluate it. Okay. We have similar type of important example. Second example, change the order of integration and evaluate integral from 0 to infinity, outer integral limits constant, and integral from 0 to x e raised to minus x square by y dx dy. Again, the observation must be limits, inner integral limits are in x. They are the function of x. Therefore, they are the limits of y, and outer integral limits are of x. So here order of integration is first y, then x. It means given strip is vertical. First y means vertical strip. Now we have to change the order of integration, means we have to consider horizontal strip. Now this is the region. If we draw these all four curves, y equal to 0, y equal to x is equal to 0, and x equal to infinity, we get this dotted region as area of integration. Now while taking horizontal strip is starting from y equal to x line, but there is no upper limit. There is no end to this region. That's why it goes to infinity. Similarly, y is varying from x-axis where y is 0, and topmost point of this region is, since this region is unbounded, there is no topmost point. It is towards the infinity. Therefore, new limits for x is y to infinity on the strip, and region limits for y is 0 to infinity. So if we write integral, we get 0 to infinity, y to infinity, first for x and then y. Then again substitution, because if you see, derivative of power is available as x dx form. Therefore, x square y is equal to t. If we put, we get x dx as y by 2 dt with the same limits. Therefore, if we solve for t, we get upper limit minus lower limit, that is 0 minus e raised to minus y. Then we get only half of integral y e raised to minus y dy, and then using u into v. So if you use u into v, first y is algebraic, so as it is, integral of e raised to minus y is e raised to minus y upon minus 1. Minus 1 comes as derivative of power. Minus, we have alternate sign. Then derivative of y is 1 here, and e raised to minus y's integral is e raised to minus y upon minus 1, and previous minus 1 gives us plus 1. And then limits from 0 to infinity. As both the term contains e raised to minus y, for y as infinity, e raised to minus infinity is 0, so entire term goes to 0 for upper limit. Minus, we put y equal to 0, so first term is 0 here, minus e raised to 0, which is 1, so only 1, then minus minus plus, so half is the answer. This way we have second example covered. So as a concept, change the order of integration means, if given order of integration is first x then y, then we have to make first y then x. In other words, if given strip is vertical, we have to consider horizontal strip, and if it is horizontal, we have to consider vertical strip. Sometimes it is difficult to solve for given limits, then we change the limits. We'll have third example here. Change the order of integration and evaluate. Integral from 0 to a, integral from 0 to root ay, x upon x square plus y square dx dy. If you see, again integral limits, inner integral limits are in y, so they are the limits of x. Therefore, given strip is horizontal. Now we will be considering vertical strip. Now while taking vertical strip, we have this region. Again, these four limits gives us four curves: x equal to 0, x equal to root ay gives us ay equal to x square, a parabola, and y is 0 and y equal to a. So these three straight lines and one parabola. If we draw it, we get such shaded region. And consider vertical strip. Given strip is horizontal. If we consider vertical strip, on the strip y is varying from. Now y starts from the parabola. Parabola equation is ay is equal to x square. Is converted into y equal to form, which is x square by a, and y strip is ending on y equal to a line. That's why these are the limits of y, x square by a to a. Whereas x varying from leftmost point of the region, which is y-axis, where x is 0, to rightmost point of the region, which is a. So x is varying from 0 to a. So with these limits, if we put, we get x upon x square plus y square dy dx. Now we are integrating with respect to y. So with respect to y, x is constant. So this is of the form a upon a square plus a square dy. We know its integral is tan inverse of y by a, where a is a constant. Here value of a is x. If we treat, then we get tan inverse of y by x simply with respect to y in the limits x square by a to a dx. Now for upper limit minus lower limit, we get tan inverse a by x minus tan inverse x by a. Okay, now this is to be integrated. Now tan inverse of a by x, its integration, we are taking u into v, tan inverse into 1. Similarly, second integral is separated and tan inverse into 1. So here u into v rule is used. Tan inverse is taken as u. So uv rule says first as it is, integral of second, that is x, minus integral derivative of first. Now while taking derivative of first, x is variable here and a is constant. So tan inverse of derivative of tan inverse of a by x is 1 upon 1 plus a by x square into derivative of a by x. So a is constant and 1 by x derivative is minus 1 by x square. into second integral. Similarly, integral of tan inverse x by a into 1 is tan inverse of x by first as it is, integral of second minus integral derivative of first into integral of second. So if we go for upper limit minus lower limit, now tan inverse a by x into x with the limit 0 and a. So upper limit, if we put tan inverse of 1 we get, which is pi by 4, into x, which is a. So upper limit gives us a pi by 4 minus lower limit x is 0, so which is 0, plus this integral as it is. Now 1 plus a by x square can be written as x square upon x square plus a square. So that x square and this x square is getting cancelled. Remaining ax is at numerator. This minus minus plus. Similarly, minus tan inverse x by a into x for the limits 0 and a. Again, tan inverse of x by a gives us tan inverse 1, which is pi by 4, into x, that is a. So a pi by 4 minus lower limit x is 0, so 0. Now minus and minus plus 0 to a. If we simplify this again, we get a square upon a square plus x square. One of the a is cancelled with this a. Remaining part is x into a upon a square plus x square. These two integrals are same, so they are added as 2 times of, whereas a pi by 4 minus a pi by 4 cancelled. So 2a into x upon x square plus a square integral. Derivative of denominator is available at numerator. Therefore, it is half of log of denominator with the limits 0 and a.
So for upper limit x as a, half of log of a square plus a square gives us log of 2a square minus lower limit x as 0, so only log of a square. So we get the situation log a minus log b, which is log of a upon b, where a square gets cancelled and only log 2. So answer is log a log 2. So this way we can solve the example. Let's take another example. Change the order of integration and evaluate integral from 0 to a, then integral from x square upon a to 2a minus x, xy dx dy. Again, the observation must be these integral limits are the functions of x, so they are the limits of y. Means vertical strip is already considered. Now change the order of integration means we have to consider horizontal strip. But we know these 4 limits are nothing but the 4 curves. So inner integral limits are of y. So y equal to lower limit x square by a gives us x square is equal to ay. Upper limit y equal to 2a minus x, which is straight line. Then outer integral sign limits for x is equal to 0 and x equal to a. So 3 straight lines and 1 parabola. If we draw, we get this situation. Dotted region is nothing but area of integration. This is vertical line x is equal to a, parabola and straight line x plus y equal to 2a. Now we have to consider horizontal strip. So while taking horizontal strip, you know upper limit for this strip is a straight line x plus y equal to 2a, whereas if we draw the strip here, upper limit becomes parabola. Therefore, limits are getting changed from the point A. So we put partition CA in the region. Of course, partition is horizontal as we are considering horizontal strip. So here we have to solve separately for two regions, region ABC and region OAC. So therefore, given strip is vertical, we are considering horizontal strip. In region OAC, lower triangular form, on the strip, x is varying from 0 to a parabola. So strip is starting from y-axis where x is 0 and strip is ending on parabola. So convert parabola's equation into x equal to form. So it gives us x equal to plus or minus root ay. But we are in first quadrant where x is positive. That's why plus root ay is upper limit for x. Whereas y is varying vertically. So bottommost point to topmost point of this region is point O, the line AC where y is a. Therefore, y is varying from 0 to a. Similarly, in upper triangular region ABC, it means on this strip, x is varying from y-axis where x is 0. Therefore, lower limit of x is 0. And strip is ending on a straight line x plus y equal to 2a. Therefore, x equal to 2a minus y is upper limit for x. And similarly, y is varying vertically from line AC to point B. It means y is varying from A to 2A. Therefore, with these limits, we get addition of two integrals. And first variable of integration is x. That's why y is constant. X is integrated as x square by 2 in the limits 0 to root ay. Similarly, second integral is integrated in the limits 0 to 2a minus y. So if we substitute upper limit minus lower limit, we get ay here only. And on this line, x square is a 2a minus y whole square minus lower limit is 0. If we expand the term, we get ay square whose integral is ay cube by 3. Whereas here, if we expand this bracket a minus b whole square, we get a square minus 2ab plus b square into y gives us all these three terms. Then once they are integrated for upper and lower limit and solve, we get the answer 3a raised to 4 by 8. So here we end the session on change the order of integration. As a summary, let's revise the thing. If inner integral limits are in terms of x, they are the limits of y, and that's why given strip is vertical on which y is varying. Change the order means we have to consider then horizontal strip where x is varying and find out new limits for x first. Okay, so changing the order of integration is if it is x and then y, make it y and then x and then solve the example.